You're able to see my screen?
Yes, sir.
Okay. So welcome to the social network analysis course. Um, so I will be taking you this course for the whole semester. So we are going to learn about something new here. So social network is one of the hot topics these days. So a lot of things happen over the social network and that is reflected back in the society also. So there's a lot of influence the social media and the social network has in politics, in sports, in social activities, in you say in any topics, the social network is uh, playing playing a very important role these days. Of course, there are some negative points also, but what we are going to look at these most of the things which are positive points, right? There are, of course, whatever the things that we consider, there are some positives and there are some negatives. So in this course, we will be looking at studying about the social networks, especially the topology, the structure, and what is the significance of the structure, and how does this structure plays an important role in the information diffusion. So information diffusion is nothing but carrying over the information from one place to another place, like from one person to another person, or from one community to another community, right? So, and then we will be looking at various algorithms to look at various kinds of community detections that we can do in the social networks to find several groups of several groups of entities which are, I mean, several groups of agents which are acting in a very similar way. So these are some of the things that we will be looking at. So before giving a kind of a brief overview about this, what we are going to see in the social network analysis, first I will take up the CIF of this course, and then I will explain you, go through those things which are mentioned in the course information file, and then we will be looking at the social network analysis as an overview for today. Okay, so the technical part of this course we will be starting from Thursday onwards. Okay, so this first day's class will be mainly on describing the CIF and telling you how you need to prepare for this course, and what are the books that you need to refer to, and how the evaluation will be done. And so after this, we will be talking about a general motivation of looking at the social network analysis. What are the applications that we have when we look at the social network analysis? And then we will be looking at we will be also looking at some of the studies that we will be doing as part of the projects associated with this. Okay, so let me start with the CIF first of all. A minute. Yes. Okay. So I saw there was a message. Okay. So it's nothing important. Okay. So let me go back to the CIF. Yes. So this is a CIF. I will be uploading this in Piazza once I start the Piazza classroom for our communication. So you can have a look at it. So social network analysis is a course that we will be looking at various the structure of the network. That is, the analysis of the structure of the network will be the first one that we will be looking at. So the structure of the network is mentioned over here. So this analysis of the structure of the network is introduced first. Then briefly, we will be talking about the content analysis, where a little bit on the NLP part will be introduced, which you would have covered some of the things in the NLP course also, whoever has taken the NLP course in the last semester. And but we will be explaining some of the things, even if you are not covered the NLP, you are not attended the NLP course last semester, you can go through these contents that we will be talking to you. So, and then that will be useful for your understanding of the social network and for doing the project on this topic. Okay. And then we will also be looking at various types of information diffusion in the network, how the information passes from one person to another. And for that, how does the structure plays an important role. So that we will be looking at. And as you know, there is a project associated with it. So knowledge of R or Python is required for the implementation. I guess most of you will be conversant with Python, so it may not be a big issue. And so this students, you should be familiar with the algorithmical way of thinking. So anyway, you will be comfortable with it because you would have already gone through analysis of algorithm, discrete mathematics, and then CP programming. So you should be definitely having algorithmical way of thinking. Okay. So algorithmical way of thinking is nothing but a stepwise kind of listing out a procedure that you want to look at when you are trying to solve some problem associated with the social network. Okay. So once you complete this course, you will be able to attain these set of course outcomes. You will be able to explain the graph-based model of a social network, how to model the social network as a graph-based model. There are various types of graphs available, so that we will be looking at in this course of the class. And then you will be able to implement various measures and models involved in describing online social networks. You will be able to apply some basic NLP tools to do the analysis on the text data, the content analysis. And then you will be able to implement the algorithms to quantify some of the phenomena on the social network. We will be giving you various kinds of measures to find the to quantify the various phenomena which is there in the online social networks. And then you will also be able to compare and contrast various types of information diffusion in the online social network. There are various kinds of information diffusion. You will be able to compare each one of them and then say that how this is different and what is the similarity and what is the difference. Okay. So these are the course outcomes. You can have a look at it leisurely when I upload this PDF in the Piazza. Okay. So coming to the content. So what are the things that we will be looking at in this course? First, a few hours of this class will be spent on the introduction to the course. That is an overview of this course that we will be looking at even today. And then we will be giving you an introduction to the social networks. Okay. And then that will be followed by some basic graph theory concepts that you should be knowing if you want to go into the graph theoretical model for studying the social network. So we will be spending almost like 2 hours of brainstorming on the basic graph theory concepts and all. So that is the first unit, which is of 4 hours. And then the main part will be coming into picture from the unit 2. That is the network measures. Various kinds of measures are there. Centrality measures are there. We will be looking at. And then we will be looking at various concepts like the transitivity, reciprocity, balance, status, similarity, strong and weak ties, triadic closure, and all. So these are the measures that we will be looking at. Some of them are really conceptual in nature, but even though it is conceptual, people have already defined some quantifying measures to find that kind of a concept, whether it is present or not, and to give a measure of it is it's a very useful one, because that measure can be used for further analysis. Okay, so in the unit 3 we will be looking at various models of network. So there we will be introducing the random graphs, and then we will be looking at the social network is not random graph. So if it is not random graph, then the natural question is what kind of model it is, and there we will get the answer that it follows a specific model called as a preferential attachment model, and it also has homophily, and it also has small world phenomena. Okay, so so these are some of the properties of the social network, and we will be showing that this social network is not a random graph in the unit 3, and then we say that it is a specific graph which we call it as a scale-free network. Okay, so scale-free networks is the type of graph that we will be looking at when we consider the social network model. Okay, and then the unit 4 will be spent on the content analysis, where we will be looking at some of the basic NLP techniques that will be useful when we look at the content analysis in the social network. And then unit 5 and unit 6 will be spent on the unit 5 will be spent on the communication in the social network, that is the information diffusion. Okay, and then the unit 6 will be spent on the behavioral aspects, and because of the behavioral aspects, how the communities are formed. So so there will be some set of people who will be behaving in a very similar way. There are some set of people who will be behaving in a completely different way from the already existing communities. So can we find those communities using some kind of good algorithms like a Newman algorithm? Okay, so there are some of the algorithms that we will be looking at, how to find the communities using different kinds of algorithms. Okay, so that is the last chapter of this course. Okay, so there are no textbook for this course actually, because these topics are chosen from 3 of these books actually. The first one is the Zaffarani and Abbasi and et al. That is the title, the Social Media Mining and Introduction. It's from Cambridge University Press. So that is one of the books that I will be referring to. And next one is by Kleinberg, Easley and Kleinberg. That is titled as Networks, Crowds and Markets. So that is another book that is again from Cambridge University Press, and that is another book that I will be referring to. And the last one, which is the book that I like the most, is by Barabasi. That is on network science. It is also a Cambridge University Press. I'm actually not advertising for Cambridge University Press. It happened by coincidence. That's all. Okay, so Cambridge University Press spends a lot of their publications towards the social network. If you want to buy any book on social network, you can look into the Cambridge University Press, because they I already have 2 or 3 more books on the social network analysis at my home, which is of very generic sense, but it is also from Cambridge University Press actually. Okay, so these are the 3 books that I will be referring to, and don't worry about this. I will be uploading all these books in Piazza. You can have a look at it. And but the last one is available in the internet. So there is a website for the network science itself, where the complete book is available for you, which is written by one of the top network science person called Barabasi. Okay, and of course this is scale-free networks, which is a type of network that we will be looking at when we are looking at the social network. Barabasi is one of the founders of this scale-free networks. Okay, so he has studied enormously, and this book is one of the best book for network science if you want to go for further research or maybe some projects associated with the social network. Okay, and the last one is meant for the NLP. So that is by Christopher Manning. You would be knowing him if you have gone through the natural language processing book or the course. Christopher Manning has a lot of YouTube videos also on NLP. Okay, and so these are the books that I will be following for this course. And the most important thing, that is the evaluation part. Evaluation is consisting of two projects. That is the project round 1 and project round 2. So round 1 will be of 10% and project 2 round 2 will be of 15%. So totally it will be of 25%, and the mid sum will be of 30% and end sum will be of 45%. Okay, so this is the weightage that is given for the evaluation method in social network analysis. Okay. So do you have any doubt in the CIF? So before going into the doubt, I want to clarify there are a few students who are from PhD also who are attending this course. So for the PhD students, the level will be a level 7 course actually. The content will be almost the same, but there will be an evaluation change for the PhD students. Instead of the project round 1, project round 2, you will be having a mini project. So mini project is it's a kind of a problem that you need to define and you need to work on that problem. Okay, so you need to collect the data, you need to do the processing, you need to do the modeling, and you need to do the analysis. So so that will be having a different kind of a CIF that I will be sharing you. Especially for the PhD students who are attending this course, so that I will be sharing you separately. Okay, so so the evaluation will become slightly different, but the most of the contents will be the same. Okay, and there will be some reading comprehensions also for the PhD students. Okay, so that is not yet completely finalized. So once it is finalized, we will be sharing with the PhD students who are attending the course. Okay. So, so if you have any doubt on the CIF, please let me know. So I will be giving you a few minutes so that you can ask your doubt. I will go back to the chat window and then wait for your questions. If you have any doubt on the CIF, please let me know. Team size will be 4. 3 or 4. The round 1 will be given just before the midterm, so that you can submit it after the midterm, and then the round 2 will be given before the end term, and you can submit it after the end term. Just like what we followed for the NLP. Okay, so if you don't have any doubt, so let me start going into the overview of this course and general introduction about the social network analysis. So let me start. Okay. So social network analysis. So I have created these slides, and some of the pictures are taken from the books by Safrani, Barabasi, or Kleinberg, so which I had mentioned in the CIF. So it's okay. So most probably I will be quoting those pictures wherever I have taken. Okay, so let me start with this quote by one of the sociologists. So when you look at the social network analysis, see, there is a part of social science and there is a part of computational science. So we are actually combining two of the topics, which is the computational science plus the social science. Okay, so we are having the computational aspect, that is from the computer science angle, and then we are also looking at from the social science angle. Because if you want to understand the social network, you need to have a perspective from the social science. So that means the behavior, like the patterns that is emerging because of the social behavior, right? So people act differently when they are in a social group, right? People act differently when they are individuals, right? So if I want to study about a group, I should not go into the individual. I should study that group as a group, right? So if I want to study about the social network analysis, both the perspectives should come together, the social network perspective and the computational perspective. Of course, we cannot go into the complete detail about the social science, because we are more of computer scientists rather than the social scientists, but we can give more type of tools and build some kind of patterns and all using the computational aspects, so that it will be helpful for the social scientists to make a proper decision, right? So if I want to look at these kind of the social behaviors, we need to look at the group as a group rather than looking as an individual, and that is what this quote is about. Okay, so just to take some time to read this quote, I will be going through this quote. I will be reading this quote for you. So for the last 30 years, I think this was way back in around 2000 or 2010, this sociologist was implying. For the last 30 years or so, empirical social research has been dominated by the sample survey. That means the social science in the yesteryears were done using the sample survey. They will go for the surveys to the people and then get the surveys done, and using the surveys they will be doing social research. Okay, but these things need not be done today, because we already have a lot of data that is available in the social network. Various types of data is available in the social network. For example, in Twitter, in Facebook, in YouTube, in Quora, in Reddit. So there are so many social network places where you can put your data, right? So these days we may not need to go for a sample survey like what we did. But as usually practiced, so what previously the social science people were doing is to sample a random sampling of individuals. The survey is a sociological meat grinder. Okay, so if you look at the survey, it is just like a sociological meat grinder. What do you mean by that? Tearing the individual from his social context, because you are getting an individual survey, right? You are not considering the social group as a social group, right? So then that means you are tearing the individual from the social context and guaranteeing that nobody in the study interacts with anyone else in it. So if you want to study about the society, you are going to look at the survey with respect to the individual, and then so if you are looking at the individual, then that means you are tearing away from the society, and then you are looking at only the individual, right? So, and then he is giving an analogy. So it is like a biologist putting his experimental animals through a hamburger machine and looking at every 100th cell through a microscope. Anatomy and physiology get lost. Anatomy and physiology get lost because of this. Structure and function disappear, and one is left with only cell biology. So if our aim is to understand the people's behavior rather than simply to record it, we want to know about the primary groups, neighborhoods, organizations, social circles, and communities. Okay, and about interaction, the communication, the role expectation, and the social control. So it is a must to look into all these topics. Okay, so then that means we need to look at the just a minute, I will take a lighter color. Okay, so we need to look at it's not thicker enough. I don't know. Okay, so let me see if this is working properly. Yeah, let me go for this. So know about the primary groups. Again, so these are the things that we need to look at: the groups, primary groups, neighborhoods, organizations, social circles, and communities. And that is what we are going to look at, the social network analysis. Okay, so and we also have to look at the interaction, the communication, the role expectations, and other things. Right, interaction is nothing but the communication. Right, so the to and fro kind of discussion that is going on, and the opinions which are shared in the Twitter and other social media websites, right? So these are the things that we need to look at when we are looking at the study of the social network analysis. Okay, so I thought this is very appropriate, so that is why I gave this quote. Right. And when we are looking at the social network analysis, what we are going to look at is two kinds of things. One is the underlying structure. Because when we are looking at the social network, so suppose we are looking at Twitter as a network. So what kind of network that you can look at? So there is a follower graph and there is a following graph, right? In Twitter, there is two things. You might be following some person, and there will be some people who will be following you. So it is not a symmetrical relation. Okay, so one way might be true and the other way may not be true. I might be following one person and he might not be following me, right? But I might be following some person and so they will not be following me. So both the things can happen, right? So if you are looking at such a kind of a network, so we need to look at the graphical structure that is forming because of this following network and this follower network. So if we consider the users of tweets as the nodes, then you can talk about the edges between them as the following or the follower, right? So it can be any of these things which is important for you. So if you look at such a kind of a network, you just think about the enormous amount of nodes will be there generally, right? So if I'm considering the Twitter as a graph, it will be having millions of nodes in that network, right? And so if I want to find the pattern in this network, and then it is going to be a very cumbersome kind of a process, because there is a large number of nodes in it and there is a large number of edges in it. Okay, so if I want to do an analysis, a manual kind of an analysis cannot be done. Only way of looking at is you need to use some kind of a automated way of computing it and then making your own inferences from the analysis that you have already carried out using the machine, right? So only the machine analysis will be possible. Human analysis is impossible actually when we are looking at such a kind of a enormous structure. But when we are looking at the social network, it need not be only the social network that I'm talking about, like the Twitter, Facebook, or the YouTube. So these kind of networks are always there in naturally in other places also. For example, if you take the astrophysicist, right? So he will be looking at the gravitational attraction of each planet in the solar system, or not only the planet. He can also look into various celestial bodies like the meteors, right? So it can be anything, right? So whatever the celestial bodies that you want to consider, you can have a look at the network of the celestial bodies according to the gravitational attraction of each of these celestial bodies, and then you can study that kind of a network also, right? So when I'm looking at the nodes and the edges, those nodes can be anything. So for example, if I'm considering Twitter, the node is going to be a Twitter user. If I want to consider an astrophysicist who is trying to find a kind of pattern in the celestial body interaction, that is a gravitational attraction between the celestial bodies, then those nodes will be the celestial bodies that he is looking at, whether it is a planet or any satellite or anything like that, right? So and likewise, if I'm looking at the molecular chemist, so when I'm looking at the molecular chemist, he will be looking at different kinds of atoms that is interacting with each other, right? So here the nodes will become atoms, and the interaction between those atoms will be becoming the edge between them. Likewise, if you are looking at the electrical engineers, he might be looking at the various electronic components, that is a capacitor, resistor, and transistors and such kind of things, and then the interconnection between them as the edges, right? So here the nodes can be capacitors or resistors or any electrical or electronical components, okay? So such kind of networks also can be studied. So whatever that you can study about a graph in as an abstract kind of a network, that can be applied for any of these studies, like the astrophysicist or a molecular chemist or an electrical engineer, and even a biologist. So biologists can also look into the various species in the ecosystem and the interaction between those species. So here the species will be the nodes of the network, and the interaction between the species will be the edges, right? So if you consider such a kind of a network, biologists will be interested to look into such a kind of network and then find some kind of a pattern that is emerging from it. So when I'm looking at such a kind of a network, various kinds of questions that you can ask. So one of the questions that you can ask is, how does the structure of the network looks like? So can you explain how does the structure looks like? So can you quantify it? So for that, we will be looking at, in the next class, we will be looking at, there are some centrality measures. So some of the nodes which are very central in nature, right? We will be looking at such a kind of nodes, and in different kind of perspectives and different kinds of types of networks. And then we will be looking at how to identify those nodes. How to identify those nodes which are central in the network, right? So it may not be only one node which will be central. There may be multiple nodes, and how to find the multiple nodes which are acting as the most influential nodes, right? So such a kind of things that we can answer by looking at these social networks, right? And such important nodes will be acting as a bridge between two kinds of networks, right? So suppose there is a country A and there is a country B, right? So if I'm looking at the interaction within the country A and within the country B, I would say that the communication will never pass from A to B, right? Because there are no nodes which are connected in between A and B, right? So if I want to have a connection between the country A and country B, there has to be some kind of a mediator, right? So if I'm looking at a political scenario, there are many countries that might be having some kind of a problem, political problems associated with their social aspects, right? And there will be some kind of a country which will be mediating it. In that way, that mediator is going to give connection to both the countries, so that the communication can pass from one country to another country, right? So that mediator plays a very important role in that, right? So if I'm looking at such a kind of a network in which the number of nodes is so huge, finding those kind of a mediator nodes will be very difficult, right? So that is why we are looking at a automated way of finding it using a more algorithmical way of looking at such kind of influential nodes. That is what we are going to look at. Okay, and we will also be looking at the information diffusion in the later part of this course, where we will be looking at such a kind of where we will not be only looking at the structure, but we will also be looking at how fast the communication grows with respect to some specific structures, right? So if the structure is helping the communication or not, right? So that is what we are going to look at. So there are various kinds of questions that we can ask when we are looking at the social network analysis. So the main point that we need to look at when we are looking at such a kind of question is so for example, if I'm looking at some of the messages in the social network goes viral, why is it so? Some of the messages doesn't go beyond maybe 2 or 3 hops. It just stops. Why is it so? Can we explain why some of the messages goes viral and some of the messages doesn't go viral? Why is it? Like some of the YouTube videos goes like exponentially. It reaches many people suddenly, right? Why is it so? Some of the YouTube videos doesn't go beyond a limit, right? Why is it so, right? And if you want to grow your YouTube friendship list, how this friendship list will be growing? So what are the integral points that you need to touch in such a way that you can bring a lot of followers into our YouTube channel, right? So these are some of the questions that is there, and we don't have a complete answer for it. If there is a complete answer, anyone can build a YouTube channel and then he can become popular, right? So, but so there is a drawback in this kind of study in this kind of scenario. Like if there is a popular person in YouTube, he will be always popular unless maybe something drastic happens, right? So if there is an unpopular video, he will be always unpopular, right? So there has to be some kind of an element of some kind of an attraction. What do you mean by that attraction? We don't know it, right? So there are some people who are successful. There are many people who are not successful at all, right? So these kind of things we will be trying to address. May not be completely. We will not be giving you complete answer for it, but the intention is to learn towards getting such kind of answers for it. Okay. So just to motivate ourselves, I just want to give some kind of a case studies, and that will be giving you some kind of an idea about why we are looking at the social network analysis. Okay. So if you want to find the motivation behind this study, so you need to look at the first chapter, that is the chapter 0 in the network science by Barabasi. It explains you some of the examples that led to many kinds of failures. So, for example, in 2003, August 14, there was blackout actually. So they people like around 60 million of people in combinedly in US and in Canada, they were without electricity. And so it is not a big thing when we are considering India, right? So we are used to not having electricity. For the Western world, it is a completely new thing. If the electricity is not there, then they cannot do most of the work, including cooking, because most of their stoves are all electricity based stoves, right? So I was also part of this as part of postdoctoral study. I was in Canada for 3 years, and there was only one incident where this electricity shutdown happened. That was because of a very severe weather, very cold weather, and so it was we also experienced around like minus 30 degree or so at that point of time. So there was a shutdown, complete shutdown of electricity in Ontario, and so we were left with so there was no cooking place for us. Like, so we cannot even cook, right? So so it's a completely different thing in a Western world. So if you are looking at such a kind of electric failure, but what was the reason of this electric failure? It was because of there was one grid in US which failed, and because of that grid which failed, the load shifted to another grid, and because of that load, extra load, that is overloading which is coming because of the failure of one grid, and that overloading shifts to another grid, and that had a cascading effect. And this cascading effect occurs in few seconds. You will not imagine, within few seconds the electricity will be gone for like around like millions of people, right? So, and this all happens because of that network, because we are having network, right? So from grid to grid we have a network, and within the grid we always have the network lines which runs through each and every home and every organization, every company, whatever is there in that city or town or the village, right? So one grid failure will rise to many grid failures, cascading effect, right? So if I want to study the network of the grids, right, I need to study about how much of cascading effect will be there if one grid fails, right? If one grid fails, how many grids might fail? So can be forecasted, right? So through the structure of the network. If it is huge, can we minimize it? Can we minimize the case like if one grid fails, not many grids will fail? So can we do that through the structure of the network? And that is what is the network science is about. Okay, network analysis is about, right? So here, when I'm talking about the network, here I'm talking about the grids as the nodes, and the connectivity between the grids as the edges, right? So that is one of the example this Barabasi states in his chapter. Okay, and there are other examples like so this is the case in the distribution of electricity, but that is not the case. We can also look into the internet as one of the example of the cascading failures, in which DOS attack. So what do you mean by DOS attack? Denial of service attack. So what has happened in the denial of service attack? So there are a lot of requests that is being generated from a single place to a server, and so that the server will not be able to serve the serve the legitimate user. Okay, so once one server is getting affected, that will be having, so that load will be shifting to another server, right? So if suppose this kind of thing happens in Google, right? So I think there was a Google failure actually, I think 2 to 3 weeks back or so. Suddenly in Indian Standard Time around 5 o'clock in the evening, so we were not able to access the Gmail, we were not able to send any mail, or we were not able to access the Google Meet. We were not able to access the Google Classroom. So my kids were trying to submit some assignments on part of the school assignment, but they were not able to do it. Like one simple small failure can have a cascading effect, because all the computers are all connected these days, right? We are not having any standalone computers these days. We don't work with any standalone computer these days. Without network, we say that it is not useful at all, right? So laptop, we need to have always connected to the internet. Mobile, it's always connected to the internet. Whenever we have a pad, it has to be iPad. We need to have connected with the network, because most of the data now these days are from the cloud, right? So you need to get the data access. You need to get some communication done through the Google Meet. So you need to have some data through the email. You need to share some files through the Google Drive. So all those things happen completely through the network, right? So you need to be in the network always. So if one server is getting affected because of the DOS network, that same load which is got from that server will be shifted to another server, and the another server also will get affected because of this, right? So it goes through that kind of a cascading effect, whatever that we saw in the electrical grid kind of a problem, right? So the same thing will be a problematic in the DOS attack also. So we can study about, if at all a DOS attack happens, what is the strategy that you can bring in, so that not all the servers will be affected at any point of time, right? So if we want to do that, what kind of structure that you need to bring up, what kind of topology that you need to have in your network, right? So that is what is the study of the network sciences about. And then we have, there are other examples also, like the economic meltdown that happened in 2009 and 2011. You can have a look at in the Wikipedia page, the economic meltdown, which started with 2007, 2008 in US. So there was a financial problem many of the banks faced, actually, because of their excessive lending for the home loans, right? And the the real estate market in US was very down, and so the banks were not able to get back the money from the people who took the loans, right? And because of that, it had a cascading effect. So the American banks were filing the bankruptcy in 2007 and 2008, and then that got reflected in European market also in 2009 to 2011. So for example, if you look at the some of the countries in Europe, like Iceland, it had a lot of problems because of this the economic meltdown, and there were a lot of issues that was felt in across the European countries also. So here also, although the network is not visible here, so in the financial system, the network may not be clearly visible, as like in a electrical grid. Electrical grid, we know the network because there are some wires which are connecting the grids, right? But when we are looking at the social network, we have a network that is associated with the Twitter, that is a follower network, and the following network, or Facebook, that is a friendship network, and YouTube, there is a follower network, right? And in the case of the denial of service also, there is a connection between the two systems. It is a network, right? So there is a clear-cut network defined there. But in the case of the financial system, the network is not clearly visible, but still people are getting affected, right? So that way, although the network may not be completely visible, it is already having that cascading effect because of one meltdown. There will be series of meltdowns that will be happening in other countries also, right? So if I want to study such a kind of a cascading events that is happening even without a network, then how we are going to study how to address these kind of issues even when the network is not clearly visible. So can we do something like building a network through some kind of heuristics or through kinds of some past history, and then try to find whether they are influential or whether they will be having the cascading effect or not, right? So such kind of things we will be looking at in this course actually. Okay. So these are some of the things that I wanted to tell you. So just to motivate you to look into this social network. And there is another example also in which, this is actually given in this link, which is given over here. So you can have a look at it. I'm not going to completely describe this. This is a very interesting story that you can look into. So the capture of Saddam Hussein, it was using the power of the social networks actually. So actually, when we are looking at such a kind of network which is not completely visible, right? So suppose Saddam Hussein has to be found out. So we need to have some kind of a knowledge about where he will be and what is his network, right? So if nothing is visible, how will you be able to get that person? But there was some kind of a hint that the social network brought about, and that brought the capture of Saddam Hussein. So for example, so there was a hierarchical tree of official organization of the Iraqi government when it came to the Saddam Hussein's whereabouts. So people, generally the US people who were like looking for Saddam Hussein, they were having these networks. They were having his government networks and all, but it was not helpful at all, because whenever it is coming to the whereabouts of Saddam Hussein, he is not in touch with the government people, right? So he is in touch with some other people. So that they found out by looking at some of the pictures of Saddam Hussein. There was one man which they call as a fat man. That this fat man was always there with Saddam Hussein, and they tried to find out who is he, and then using his network, they were able to find the Saddam Hussein's whereabouts, and they were able to trace him. Okay, so such is the importance of finding the network. Whether it is positive or negative, it depends on your kind of objective, right? But it is helpful in this way, whether it is positive or negative. The way is to find, using the structure, we are trying to achieve some kind of an objective which will be positive in nature for us. Okay, so that is the thing that is given in Barabasi's book. You can have a leisurely reading of all these things. Okay. So until this point, do you have any clarifications to make? So let me give you a few minutes. So today's class will be more like a story, if you have seen it, right? So I'm trying to build some kind of a story around it so that it will be useful for you to motivate yourself to study this. It's a very interesting topic to study. Okay, so if you don't have any doubt, let me continue for a few more minutes, and then we will stop. Okay. So whenever we are looking at the social network, we are talking about the interconnectivity. So the interconnectivity is the one that we are looking at. That is a connection between the nodes, right? If no nodes are connected, then there is nothing like social network. Everybody is a separate island. So there is no security violation, there is no privacy violation, there is no cooperation, there is no communication, nothing is there. And then everybody will be living their own life. If they want to, if they are having bad health, they will be dying. If they are having some happiness, they will be enjoying. So it's completely disconnected, right? So that kind of a network we will be never we will have in the world, right? So in the world we will be having connected networks, right? So whenever there is an interconnectivity, there is something good about it and there is something bad about it also, right? So suppose if there is one grid and that grid is connected to some of the home and there is no other grid which is connected to it, right? Then that grid won't be affected by the failure of any other grid because there is no connectivity. So there is only one grid. So you need to make sure that the electricity is generated and then that is passed through that grid. So if you make sure that, then there is no problem, right? So if you want to have such a kind of a connection where there is no connection at all, then that is not useful. In a power grid, you cannot store the electricity, first of all, right? Whenever the electricity is generated, that has to be supplied somewhere. It needs to be spent somewhere, or else it will go waste, right? You cannot store it, right? So if that is the case, then you need to have connection. And if you have connection, then there will be some problem like if one grid is having a failure and then the other grid might be having failure, right? So interconnectivity will be good, but it is also having the same kind of badness associated with it, right? So connectivity brings both benefits and vulnerabilities together with it. And that is a challenging problem for us, right? So there are things which is the connectivity is bringing benefit, and there are some connectivity which is giving you vulnerabilities. So it is the same in the social network analysis, in the social networks also. You might be having some good friends, you might be having some bad friends. So social network can be used for good things also, it can be used for bad things also, right? So you need to use it in a better way so that you will be able to get good things out of it, and it is going to be useful for the society, right? So the cascading failures need not be only negative. So for example, if I'm looking at the power grid failure, it is a cascading failure, right? So if that kind of a failure is occurring for us, it is a negative one for us. It should not happen, right? But if that is happening for a terrorist organization, like for example, you are draining out the money supplied to the terrorist organization, then it is a positive one, right? So whenever I'm considering a cascading failure, the cascading failure can be positive also and it can be negative also, okay? So whichever is good for the society, that's what we need to take out, okay? And another example is the cancer research for using the cascading failures of cells in order to cut the cancer growth, because the cancerous growth is going to spread for the other cells. If you are able to stop that growth, that is, you are stopping the cascading effect of those cancerous cells, and then that is good for you, right? So that is the thing. So the cascading failures need not be only negative, it can be positive also. So there are many networks that you can look at. So internet itself is a very, very large network that you can look into. So internet consists of a lot of devices. It can be routers, it can be switches, it can be computers, all kinds of computers. It can be some mobile devices also. Like, so all those computers, mobiles, switches, routers, everything are connected to each other. And so we have an internet which is having some maybe billions of nodes in it, and there may be some millions of edges also in it, right? So the network is going to be huge for us. Okay, so what we are going to look at as a network is not 4 edges and 10 vertices or something like that. We are going to look at some millions of nodes and some millions of edges, something like that. Okay, and there are other examples like the structure of an organization. So for example, you take the organization like Microsoft. So how is this organization is structured? Whether it is having hierarchical structure or it's a non-hierarchical structure, right? So what is the topology of it? Can we study that? So such kind of things we can study. Okay. So here, if you see, there is a structure which is given of an organization. So here, the red, blue, or green is the nodes that are labeled with the colors are the departments, and the yellows are the consultants, and the gray is the external experts. How they are connected with each other. So that is what it is. This organization is giving. Okay. And this is another example which is taken from Barabasi. So this is with respect to the business ties in US biotech industry. Okay. So these are some of the networks that we will be looking at. So this is a network with respect to the terrorists who did that September 11. I think September in 2001, right? So yeah, in 2001, the Twin Tower, yeah, which was brought down by these flights, US flights, right? So this is this network of those people, these terrorist organizations. So these are the networks that we will be looking at. The networks will be huge, and for that to study, we will be looking at various concepts like the random graph, and then we will be answering whether the social network graph is really random or not. So there is a strong feeling that every social network might be random, but it is not random actually. It is a specific kind of a graph which is called as a scale-free network. And then what are the, if it is a scale-free network, we need to define what do you mean by scale-free network, and that defines the patterns of this graph. And then we will be looking at various kinds of strong ties, weak ties, and then triadic closures, some of the centrality measures of the graphs, and then we will be looking at small world phenomena of the social network, and then preferential attachment in the social network, and then how the communication passes through the network, and how to define the community and detect the community, right? So these are the things that we will be looking at in this course. Okay, so this is a complete overview. I've not defined anything as of now, but I'm just trying to give the whole picture of what will be there in this course. Okay, so let me stop over here for today's class, and I will wait for your questions if you have any. So from the next class, we will be starting to look into the various technical topics. So I'll go back to the chat window.